Hi, folks. Today I'm going to present on a topic which lies at the very core of actually mathematics, but information and communication technologies as well. So I'd be really talking very briefly on these topics. And there's a disclaimer that the definitions that I write here are my own. You may not find them in a standard textbook, but I don't think your professor would get offended by these definitions at all. So here we go. Navigating the ICT alphabet soup. It's an alphabet soup, right? And the associated semantics. All right. So there are terms like signal, measurement, information, data. It's everywhere, right? Keep hearing about data processing, data transmission, this and that, big data. Then there's the concept of coding, communication, computation, and finally, perception. All right. So, just a note that I'd share this presentation at GitHub sometime in the coming few days, and you can find the link in the comment section uh, accordingly. So we move from here. Let's first define what is a signal, right? You must have heard, uh, a lot about signal. So let's define signal. It is an important definition. A signal is a measurable and controllable change. The most important aspect over here is change. A signal is a measurable and controllable change in a changeable aspect of some perceivable entity. It's a mouthful, but don't worry, we'll explore it. And it's not over yet, anyways. So, through changing the attributes of such an entity, information is encoded. All right, now let's take it a bit at a time. So, the most important thing is that a signal, let's look at the later part first. So, a signal carries encoded information, right? And how exactly is that information encoded in it? By changing the attributes of some entities. All right, so far so good. So we're moving backwards. But how do we change the attributes of such an entity at all? Well, we can only change it if they're changeable. If for whatever reason they are immutable, they are not changeable, then there's no signal, there's no information, there's no nothing. That's why changeable is important, and it has to be controllable as well. Controllable means that the change cannot be random. The change has to be in proportion with the degree of control that you or I or any perceptive mind wants to award to it. All right. So controllable is important. Not everything that's changeable is controllable as well. It has to be controllable, and we'll see why. Moreover, it has to be measurable as well. That change, that controllable change that has been done by changing the attributes of a changeable entity and hence encoding the information. Somebody has to read or receive that information as well and perceive it accordingly. That cannot be done unless that change is measurable too. All right, now let's take each of the important attributes um, separately, although I have mentioned it uh, briefly as well. So the first attribute is perceivable. So some aspect of an entity needs to be perceivable, right? If it is beyond perception, well, then its existence or lack thereof is of no use to anyone, either the person transmitting or receiving the information, because perception is the um, common denominator of everything, basically. So if a change is not perceivable at all, then whether or not it occurs is really immaterial. Hence, so we move forward. Changeable, then the aspect needs to be changeable because it is that change which actually represents information, right? So let's say you think of a piece of conductor, a wire, which carries some, let's say, electrical current, and it's, let's say, if it's constant, then you cannot really use it to send any information on a constant, on an attribute that is constant, right? If it varies, then you can. So moving on from here, as mentioned earlier, it has to be controllable as well, right? Because controllable means that the aspect needs not just to be changeable, but changeable at will and to the degree desirable, right? This, as we mentioned earlier, is very important because unless I can control the change, how can I, as a perceiving mind, as a perceiving entity, really use any kind of any aspect of any perceivable entity, right, to carry information that I wanted to carry? It's only through change that I can do that. A change that I can control too. Moving on to the next attribute of the change, it has to be measurable because once it's transmitted, a signal is carrying information. For somebody to perceive that information again, that change has to be measurable. Even if it's somebody, some entity has sent some information by changing the changeable and controllable attributes of anything. If it is that change is not measurable at all, well, then I cannot receive it. Then no perceiving mind can receive it. Well, because it's not measurable. How do I measure it? So over here we mean somewhat inverse of controllable, right? So when you control changeable attributes, you send information. When you measure it, then you kind of receive it. The controlled change of the entity's aspect should also be measurable. Well, and if a measurement method does not exist to measure the controlled change, then information cannot be received. And finally, we come to the change itself. What is that is changing, right? We'll see. Because this is related to the definition of information and encoding. And we'll see it in a few moments. But before that, let's define data. So, a disclaimer, I really don't like the extremely overloaded usage of this term. So, let's keep it simple. If you really think about it, data is nothing but a set of changeable, measurable, controllable state of aspects of some entity, right? And it may or may not be retained, but that's quite besides the point. The important thing is that data is just out there. There is no such thing as data. There are only attributes of different physical uh, phenomena in the real world. And the phenomena could be electromagnetism in a hard drive, let's say electromagnetic basis of encoding information is there. Mechanical arrangement in an abacus. Abacus is a mechanical calculator of sorts that was used in history. or even if it's an electrobiochemical state in a human cell. We know now that biological signaling is fairly complex. But with respect to the data, data is a passive thing. That is the most important thing to understand. It is not related. It does not have to be related to perception. Perception is the real thing that sets everything in motion. Perception is the basis of information, of computation, and really of everything. Data, as opposed to that, it's just a passive thing. It is only a perceiving, controlling, measuring mind that gives any meaning or purpose to data. So we'll see. This will make more sense in a few moments as we move to next slides. So what then? If not data, then what else then? There are more useful terms because we have to make use of things, right? We are, as humans, we are tool makers. We make use of things. We engineer things to suit our objectives. And to that, um, you know, to that, as a means of achieving that objective, there are other terms which are more useful, other terms, other concepts, and those are information, computation, and representation. And we'll see more. We'll see them. We'll explore them one by one. But before all of that, let's talk about knowledge. What really is knowledge? Well, I'd like to define it as, knowledge is a set of everything that a perceiving mind knows at any instant of time. So let's say right now, when I'm recording this video, there is some time. Everything that I know is my knowledge at this moment. That's about it, right? It does keep on changing. But the definition is this: it keeps on changing with respect to time. So it has two anchors basically: the concept of knowledge. The first anchor is the perceiving entity, some conscious perceiving entity, which in this example happens to be me. And the other anchor is time. Because with respect to time, that knowledge that a mind, that a perceiving entity has keeps on changing. This concept of knowledge, we can, if we delve into any further than this, then, I'm afraid we'll enter another alphabet soup of sorts. So, which we might choose to do in a later video, right? So let's move to our other topics related to the task at hand. All right, so now we come to the concept of symbols and representation. Okay, so what really is a symbol? The term is used in common natural English language as well, and pretty much in a sense, in the same manner as it is used scientifically. It's not too different. So a symbol is just something that represents something else. That's about it. A symbol is something that represents something else. Okay, simple, isn't it, right? And that representation often, almost always, if not always, is done through encoding, right? So we'll explain that in examples. So let's say 9, the digit 9, what is this really? This is a representation of a number, which is just a concept. Right? You have to understand that number itself is a concept more than anything else. Any number is a concept. What I have written over here, 9, is just a representation of that concept. It's a placeholder, a representation. And that representation is encoded in a decimal number system. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the decimal number system. Similarly, the same number, similarly, the same number 9 in binary encoding is represented this way: 1001, 1001. It's again the representation of the same number, which is a concept, by the way, which is not a real thing per se. It's a concept. Well, real or not, let's leave that, but it is a concept. And this sequence is just its representation encoded in a binary number system. All right. So let's take a non-technical example. So let's say in politics, let's say if it's US Congress or elsewhere in Pakistan or India, there is a member of National Assembly. Who are they really? They are a representation of the people who elected them, right? That is what we say. We say that our politicians are our representatives. They are a placeholder for us in the right forum. They represent us. They are not us, but they represent us. That representation is also encoded. How exactly? Through the political system. You have the entire political system of our constitution and elections and so on and so forth, courts and the election commission and this and that. All of that is encoding. It's the details. It does not change the fact that a congressman, woman, or an MNA is just a placeholder or the representative of someone else, the people. And it's exactly the same way in the above two examples, which happen to be more technical and more suitable to what we are doing here. Okay, with that, we move on to the concept of information. So what really is information? This is the age of information technology, as we say. But what is information really? Okay, think about it this way. Information is just knowledge in transit, nothing else really. Say that again. Information is knowledge in transit. By knowledge, it does not necessarily mean that it's the entire knowledge of any mind or perceiving entity. It could be a subset, as it often is, but it is a knowledge nevertheless. That's about it. So let's see what is really happening when we talk about the concept of information. So the knowledge of a perceiving mind is encoded into symbolic representation, and the transit occurs through a signal. So, okay, if it's seems like a mouthful, but we have covered all of this already. So remember, perception, the perceiving mind is the real common denominator in all of this. So a perceiving mind has some knowledge at an instant of time. A subset of that knowledge is encoded. Let's say if it was that number 9, I have a knowledge of that number 9. I encode it, let's say in a binary representation system. And that binary system is symbolic. Why is that so? Because what it is representing, the digit sequence, the binary digit sequence 1001, is a symbol for the concept of the number 9. And then this knowledge, which has been encoded into a symbolic representation, is transmitted through a signal. We have already discussed what a signal is. It could be anything. That signal could be really anything. And we'll see some examples later. So what happens? The knowledge is transferred, and then at some other end, the receiving end, there's another perceiving mind What does it do? It gets the signal, it decodes the encoded symbolic representation of knowledge, right? Which happens to be the binary digit sequence corresponding to the concept of the number 9, which in turn is a subset of my knowledge, I who had transmitted it. And then the receiving mind perceives it. It also thinks of the same concept, the same thing, which is called a number 9. That is the sequence of information. So when somebody has received that information of 9, of the number 9, what does it really do to him or her? To that perceiving mind, what does it really do? What does this information do? What it does is that it adds to the knowledge of that perceiving mind, doesn't it? Well, let's say, for the sake of discussion, that the person already knew about the concept of number 9, right? You could argue that nothing has been added to the knowledge of the receiver, of the receiving perceiving mind. But hey, think again. There is something which has been added, and that is that the number 9 has been transmitted by some other perceiving mind, the transmitter, at a certain instant of time, right? That is new information. And it could have other associated things attached to it, like I was sitting at that time. The weather was beautiful. The sun was shining at that time. So that is always the case. Information, even seemingly redundant information, always adds to the knowledge of the receiving, perceiving mind. All right. All right. So with the concept of signal, information, representation, and symbols which are related, uh, now that having discussed all of that, let's touch another concept, that of a computation. So what really is a computation, right? There's an entire theory, by the way, called theory of computation. It's very nice, but I'm not going to be um, too academic. So the way I prefer to define computation is this way: any state transition under the control is important, under the control of a perceiving mind, can be characterized as computation. That's about it. Okay. So we'll see this in an example as well. So there are some concepts that we discussed earlier when discussing information signal, etc., which are relevant here as well. We have to be talking about attributes that are measurable, changeable, and controllable. See, there is the state transition is a fundamental thing in the concept of computation. So what really is state transition? It cannot be random, right? It has to be controlled. The state has to do transitions. We'll see some examples too. All right, so this is the first example. Let's say this guy, there's an eye, and this is the perceiving mind behind that eye. And let's say that perceiving mind either sees this green square or this red square, right? And it gets to perceive that the block is either green or it is red. So let's see what is really happening in terms of the definitions that we made. There is just one perceiver over here, by the way. So this is something. There is some information here that there's a block which is green or red. It has a color, and that color can be either green or red. So as we know about human eye optics, that light signal enters the eye. There's some processing which happens in the eye, then the optic nerve carries that signal into the brain where it is perceived. But if we, let's say, abstract out all of those complications, in a sense, on a block level, what is happening? What is happening is that this information, the greenness or the redness of this block, is represented, is encoded through some representation in the light waves that are coming from this source or this source, whichever it happens to be at the moment, and they are coming into our eye. Our eye has a mechanism of decoding that encoded information and also of perceiving it. All right. So let's take another example. This is also an example of a signal that is carrying information. Let's say there's some guy who says, hello world. So hello world. And let's say there's some other guy, within the earshot of this guy A, and let's say this is B. And this guy B, he just hears it, he perceives it, right? So what's happening? Let's explore. So when this guy says hello world, there are there's a signal that is generated. There's a change in measurable, controllable aspects of the air in the surroundings of the speaker. And specifically what that is that a mechanical wave, a set of compactions and rarefactions, a change in pressure and other attributes of the air happens with respect to time, and it happens to the air in this entire area, right? And that is the mechanism of encoding that speech. So what happens when these vibrations of the air hit the perceiver through his ear? Well, the ear also has an eardrum, and there's a complicated human uh, hearing perception mechanism. But in a sense, the eardrum also vibrates. And the perceiver, our mind, our brain, it perceives it as hello world, right? So where is the signal? These changing waves, the air waves, the changing physical properties of the air over here is the signal. How exactly is it encoded? Through a change in the measurable, controllable properties of the air, which correspond directly to what has been said. And it's controllable because when the guy says, hello, world, the human um, vocal system is doing some very specific controlled changes, which result in very controlled changes in the surrounding air and all the way through. See how this is how it happens in terms of the definition that we just saw. All right, so let's take another scenario. Data means nothing really, nothing at all, nothing. You might find that very surprising, Data is everything these days, or so we think. But think again. So let's say I have a 1 terabyte hard disk, and it has, lots of music, lots of photos in it. The entire 1 terabyte is uh, entirely consumed. Okay. Let's say I somehow happen to put this into a time machine and bring it to the time of the caveman, you know, many years ago. And this guy is sitting inside his cave, and suddenly this 1 terabyte hard disk appears, uh, from thin air, so to say. What will he do? What will he really think? What is happening? Will he be able to um, take this music and photos and perceive them? Will he? Clearly, he won't, right? What would be the value of this hard disk to him? Nothing, probably. Probably he could use it as a paperweight, as a weapon to throw it at some intruder or enemy, right? Or a useful piece of metal and plastic, which he could, make a spear from to use in his hunting, but nothing more, right? Where did that data go? Where did all of these music and photographs go? Where? They seemingly disappeared, did they? Well, yes, they did. Why? Because they were not there to begin with. What was there in the form of music and photographs was the information stored as data. And what is data really? Let's say if this hard disk used electromagnetic means of encoding all of that, multi-layer encoding. Let's say if we abstract all of that away, it does not change the fact that there is some physical, changeable property of elements inside this hard disk, which carries all of this information. But does it mean anything to this caveman? Not really, not at all. And that is why data is quite meaningless. Because what really gives meaning to it is the knowledge, the perception of the encoding, right? As well. Without knowledge of that encoding, that data is meaningless. Yeah, sure, a physical process is there, some physical properties are being used, but if there's no encoding available to the caveman, it does not mean much to him, right? Similarly, let's say an abacus. Um, Abacus is basically, uh, you can think of it as a primitive calculator, a mechanical or a calculator. Let's say, for the sake of discussion, that this abacus shows decimal representation of the number of millions of years left till the universe will end, right? Let's say. If I were to put this abacus magically in the cave of that caveman, would it mean anything to him? Let's say if he belongs to the pre abacus area. Not at all. Not at all. All it is using is, let's say, some piece of wood or metal or anything with some mechanical arrangement of these beads, but it means nothing to the caveman because he does not know what this encoding is, what this sequence of beads means. He has no knowledge of that, right? So he'll, just play with it or make a spear out of it or give it to his kids to play with, but it means nothing. I hope this gives you some clarity. All right, so we will go move on to the next example scenario, which is that of a computation. Let's say if we have a CPU, a central processing unit, and for the sake of discussion, it has two registers, R1 and R2, and another register A0, which carries the result of computation. Let's say there's an instruction set of this CPU, and there's an instruction whose mnemonic is add, and in parameters, it expects two registers, and it stores the addition result of R1 and R2 in A0, right? So those of you who have studied computer organization and design and similar subjects would clearly know what we're talking about. But I'd like you to think of it in other ways also. So let's say at time t0, this is the state of these registers. R1 has this binary sequence, which is decimal 1. R2 has this binary sequence, which is decimal 4. A0 has this representation, which is 0. At time t1, we execute this instruction, add R1, R2 on the CPU. And at time t3, what it does is that it gives the result in, so this is a typo, I meant A0. So it stores the result in A0. And the result is this 101, which is a decimal 5, as it should be. 4 plus 1 is equal to 5. And let's say the instruction is designed in such a way that it clears the operand registers R1 and R2 and makes them 0, right? So let's say this has happened at time t0, t1, and t3. So let's understand what is really going on. These registers basically they maintain logic levels, binary. Uh, they are composed of binary digits. Let's say these are basically 3-bit registers. They have 3 binary digits, and those in turn, the logic level 1 and 0 are in turn nothing but electrical, very um, very intricate, sophisticated electronics, but electronics nevertheless. They correspond to laws of physics, and it's very carefully engineered and designed. But let's zoom out again. So clearly, you would agree that a computation has taken place over here at time t1 because addition is clearly a computation, right? And the result has been stored in this register. Okay, now let's think about it further. What we call as computation, what really is it? It's nothing but state transition. The state of this register A0 has just changed as a response to execution of this instruction, which again is symbolic. This mnemonic add corresponds to some other binary sequence, right? So all computation is nothing but controlled state transition. And that's about it. So how is it that we are able to do so complex computations, processing, and do stuff like record YouTube videos, listen to them, make complex software programs. Where did all the software go, right? Where is it? I'd like you to reflect over it. We'll probably talk about it in a subsequent video as well. We'll take it from here. But when all is said and done, when all is really said and done, all of that software is basically in the perceiver's mind. That's all about it. So I often like to say that software is just our thoughts in action. So do reflect on it. And finally, I leave you with some homework. You think about these two questions. The first one is it possible to compute without generating information? Think about it, reflect on it. Second question is it possible to generate, transmit, or to receive information without performing a computation? I'd like you to think about it as well. Reflect on it. Consult this video again if you have to, and then maybe let me know the answers in a comment. And I'd like to thank you for watching this video. I hope it was useful. This is an area of my passion and interest. And if you like such content, then you can subscribe so that you can be notified whenever such content is available in the future. And with that, I'd like to end this. Thank you. Bye. Have a good day.